Hey guys, Creative58 here. Today we are back with another video. However, this is different from the previous video, so I'm actually teaching you. However, barely any of you will be doing A-level statistics because it's the most unheard of, unpopular A-level. Anyway, you can't read this, but I can. So I'm going to be explaining it to you, so you get to listen to my pretty epic voice. So, as you can see up here, we are doing the Poisson Distribution. In French, is fish. You're a pretty epic fish there. Now, Poisson is a discrete distribution, a special discrete distribution. So, let's get into the video. So we can use it in situations such as like approximating a binomial distribution. So we can use the Poisson distribution to approximate a binomial distribution. Now, for you that don't remember, a binomial distribution's parameters are n and p, n being the numbers of trials, p being the probability of success in a typical Bernoulli problem. Now, we have the distribution of random events, which is what we're going to be focusing on today, because I'm pretty sure that's all we need to know. If not, I'll double check the spec and make part 2, so lucky you. Let x equal the number of scenarios, so just say accidents per unit area. So if we're going to do our example here, let x equal the number of accidents per stretch of motorway or something, and then what's the probability of 10 accidents happening on 8 stretches of motorways, and then you would use the fact that we need to assume a constant rate to work out the new parameter. Speaking of parameter, x is modelled as the Poisson distribution. We can use lambda, or we do use lambda as the parameter. So, well, when x follows the Poisson distribution. The Poisson distribution is known as something called a counting distribution, and it can be used in the following ways. As we mentioned, approximation of a binomial distribution, or distributing some random events. Now, like any other distribution, there are conditions you have to follow, such as this one. The event must occur singularly in space or time. So space means, so like up here we gave the per unit area, so that's the space. So per stretch of motorway. Singularly in space / time. Time being, this many events happen in 5 minutes. Calculators, whatever, independently of each other. One event isn't going to affect the another event, so they're independent. At a constant rate, now that means we can do this. So, if we have, what do you call it? I'll draw this a bit bigger. We don't need the top anymore because I've already spoken about it, so I'll demonstrate it a bit more. Clearly. So, what we can do is, I'll just make this part bigger so you can see it. So, x following a Poisson distribution, and just say we have lambda, we'll do the accidents on a highway, so let x equal number of accidents per meter on a motorway. Yeah. So we got number of accidents. Oh, did we stop on that? You didn't see that? Number of accidents per meter on a motorway. Now, I don't know, just say we had 5 accidents. Nah, it's a bit too high actually, ignore me. We have 1 accident. Yeah, okay. This isn't realistic, by the way, so this is just an example. So we have 1 accident per meter, so we write that like this. So that's a slash, by the way. I'll make that a bit more diagonal, to make it more obvious that if you're doing an exam. Yes. Now, constant rate will allow us to do something quite fun. So, what's the probability of 7 accidents occurring in a 5-meter stretch? Now you're probably thinking, I have no clue. We're given 1 meter. Oh, this pen is so what we do is we can use the idea events occurring in space at all time, so to speak, is directly proportional to the number or the mean number of events in the scenario. Correct? I think so. I don't think so. I know so. So we do x2, if we call this x1, just for ease. So we've got x2 following the Poisson distribution. We want it following a 5-meter stretch. Yeah? We're looking for 7 accidents happening on a 5-meter stretch. So another way of writing this is rewriting the distribution. So if we're doing a 5-meter stretch and we already have 1 meter, we simply times that by 5. But if we times that by 5, we also have to times this by 5, meaning 5 accidents happen every 5 meters on the motorway. Now, that is our new distribution, and we are trying to find the probability that exactly 7 occur. Now, we can use the second part of this video, or I guess you could say that, so the wrong time after we've essentially rewritten over that. Now, what we can do is, as long as we've got a probability distribution, which is basically this, like this form of thingy, yeah, I'll write it a bit larger here. A probability distribution is like that. And there's an equal sign here. And a cumulative distribution is when you it's like when you do that, isn't it? So that is cumulative, this is probability distribution. So, well, it's denser than that, but yeah, you get that. It doesn't matter what it stands for, use PD when there's an equal sign, CD when there's a greater than or equal to sign, or so on and so forth. Now we've got, I need to move it up. So we've got Px equals 7. Now we can use the following formula. So Px equals x. Now the following formula for this, you might not be able to follow it from here. I'll rewrite it here actually. Big brain tactics. Go on, fuck it, break the TV here. There we go. Make a lot of unnecessary noise for no reason, but anyway. Px equals x. Now this is going to be the formula, I guess we could say. Px equals x, and now that's going to be equal to something called e. Now e is a button on your calculator. I digress. So e to the power of minus lambda, yeah. So that is e to the minus lambda. Multiply that by, we multiply that by, what do we multiply that by? Lambda to the power of x. And then we, as the denominator, we have x factorial. Now, you're probably wondering, what's x, what's lambda, what's happening? So, remember we're solving the question for this distribution. Okay, so as you've previously seen, the parameter of the Poisson distribution is lambda, meaning this lovely value here is lambda. So in theory, this is going to give us, we solve this now, e. E isn't a number. E, well, I mean it is, but it's a thingy on your calculator. You can click, turn it on the Poisson PD. We can click alpha, and then we can click the times 10 to the power of x, and then you get an E button. Now that is given a preset value, almost like LM2 is 0.693, something like that in chemistry, potentially. I can't remember. Don't take my word for that. Take my word for this, though, all this is correct. Minus 5, yeah, we've got that part, minus lambda. Now we multiply that by lambda, we know that's 5. But now we are greeted with x What is x? Let me tell you. Probability big X equals x. Now up here we saw x, this is big X, is the number of accidents per meter on the motorway. So the number of accidents on the motorway equals x, or the weird mathematical x. Now that is going to be a number we are given. So in this case, x in this place is 7, so that's equal to little x, so to speak. So our question is p x equals 7, given now this, yeah, so we've got 7, so the 5 to the power of 7, and then we do 7 factorial. Now 7 factorial was basically 7 times 6 times 5, all the way up to 1, now give me one big number. It's also used in, I think, binomial expansion, yeah, I think that's correct. Now we can calculate that, or we can type it into the function. I'm going to do both just to show you they both work. 10 minus 5 times that by 5 to the power of 7 over 7 factorial, and that is 0.104. Yeah, I guess we can leave it to 3 EP. There we go. That's to 3 decimal places. I calculate from the equation. Yeah, that's correct. So, don't know if you can see that. I'm not looking at my camera that much because it's on my phone. And so. Now we can go on to menu 7. We can click the down button and we can go on to Poisson PD and variable. Now it's PD because we're given an equal sign here, not CD. PD. Now, x is, so you'll get a brief of the screen like that. Yeah. X is equal to 7, because we're trying to find that. And lambda, or yeah, the parameter for the Poisson distribution is 5 in this case. And, you never guess what? We got exactly the same thing. Yeah. We got 0.104. So on and so forth, but 3 decimal places we got 0.104, meaning that this is correct. I'm right, like always, and we are good to go. So, just to recap, probability x equals x is equal to e to the power of minus lambda times by lambda to the power of x divided by x factorial. Now, x2, following the Poisson distribution, 5 accidents per 5 meters, given that x is equal to the number of accidents per meter on a motorway. Now, e to the power of minus lambda, lambda being 5, so e to the minus 5, times 5 to the 7, because lambda is 5, x is equal to 7, over 7 factorial, given that 7 is x, and obviously factorial is just factorial. Put that into your calculator, or do the easy way, which is probably better in the exam, given that this is probably going to take you longer than typing numbers into a calculator. Is your answer. Boom. So, guys, if you liked that video, drop a subscribe, that would be much appreciated, and thanks for watching. And if I taught you something today, subscribe to that, yeah. Funny moments. But yeah, also my intro at some point. Yeah. You guys are looking at the back. So that's my stats classroom. So with a little in my pocket. But guys, next week I am covering the binomial distribution, and we're gonna, yeah, obviously we're gonna be covering just binomial. So guys, thank you for watching.